Good morning and welcome everyone to this webinar as part of the RSC series discussing climate change and sustainability as we look forward to COP26 in November in Glasgow, the United Nations Climate Change Conference. I'm John Broderick. I'm the Climate Change Policy Advisor for the RSC, and as you'd expect, through this programme, the RSC is going to be showcasing how chemistry is vital for understanding and tackling climate change through a series of online events. We'll be recording this session and the others in our series, so that if you've missed out on any, you're very welcome to watch those back. And please do visit our website to find out more. The short link is rsc.li/COP26, and that needs to be in capital letters for that to work. And you'll find out about the other 19 or 20 events in this programme. So today I'm very pleased to welcome Dr. David Joffe of the Climate Change Committee for the first of a series of members-only events where we're hearing from experts from outside of our chemical science community on the big contextual issues in climate and energy. These sessions will be running weekly until the COP, and today Dr. Joffe is going to give us an introduction to the carbon budgets and the science of carbon budgets and targets towards net zero. We'll have a presentation for about 30 minutes and then move on to a Q&A. We'd encourage you to ask any and as many questions as you like. These can be added through the Q&A function that's in the middle of your screen down at the bottom. There's no such thing as a silly question. We're all amongst members here. The silly questions are the ones that you don't ask and leave you hanging. And I encourage you to do that while David is talking so that things don't slip out of your mind. And we'll have plenty of time for discussion and conversation at the end. So without further ado, I'm very pleased to hand over to David for his presentation. Thanks so much.
Thanks a lot, John, and good morning, everyone. I'm just going to share my screen. Okay, hopefully that's working okay. Well, good morning. So I'm, as John said, I'm David Joffe from the Climate Change Committee. The Climate Change Committee is the UK's statutory advisor to UK government and Parliament on climate change. We also advise Scottish government, Welsh government, and Northern Irish executive as well. We advise both on the level of targets and on and monitor progress towards meeting them. So I will talk about very much the advice we've given essentially on targets, but also the pathways that we have towards meeting them. And we are eagerly awaiting, it's fair to say, the government's net zero strategy in the next couple of weeks or so about how it thinks it can meet the net zero target and the targets on the way to that. I'm going to start with some physical science. I'm a former physicist myself, if you'll forgive not being a chemist, but what I focus on mostly is the energy system and the transition to net zero in the UK, so much more on the how do we do it rather than why are we doing it and what's the physical science. But I will talk through that and hopefully that will be clear enough. All right, so I'm going to start with this. It's a good slide to start with, to say actually we're pretty confident that not only are humans affecting the climate, but essentially all of the warming that we've seen in the last 150, 200 years or so can be attributed to human activity and the emission of greenhouse gases. The orange line is what we infer from what we understand of the climate system, the models that we've put together and iterated on over the years, and that explains extremely well the observed temperature data that we see from all of those other lines, with obviously fluctuations around that because the climate is a complex system. But broadly speaking, we are very clear that humans are responsible for essentially all of the warming that we've seen since 1850. So that's to say we think we know what's going on, broadly speaking. There are, of course, some uncertainties, but the science is increasingly clear and increasingly clear what we need to do in terms of emissions reductions. If I move on then to the global picture for what needs to happen to emissions to stay within 1.5 degrees of warming. Now we're at about 1.2 degrees of warming already since pre-industrial levels. So 1.5 is actually, that's a very stringent limit. And you can see in these graphs what has been happening to emissions globally over the last 30 years or so, and what needs to happen to emissions in the future in order to stick within that limit. And it's very, very far from business as usual. This is a pretty extreme break in the trend of what we've been doing to date. So that's the global picture in terms of what needs to happen globally to emissions. You'll see on the left-hand chart there a dot in 2050. So the left-hand side is all greenhouse gases, and the right-hand side is CO2 emissions only. CO2 is the dominant greenhouse gas, but there are others. We've set a target in the UK for net zero emissions of all greenhouse gases by 2050. Now that's about 20 years earlier than the climate models say that we need to get to net zero for all greenhouse gases for the globe as a whole. So it is, in that sense, going beyond just an equal share of responsibility, but there are many reasons why the UK should be going earlier, because we've actually started before many other countries, because we have a huge historical responsibility in terms of the greenhouse gas emissions to date as an early industrialized country, and because we can afford to do so. So that's the target that we've set. People often say, well, net zero emissions in 2050, that's just the global, that's what needs to happen globally, so we're not going earlier. But 2050 net zero emissions is for CO2 only. As you can see on the right hand side, the purple line there, which is the 1.5 degrees line, goes through net zero CO2 in 2050. But actually for all greenhouse gases it's 2070, and I'll talk about the other gases in a minute. Okay, so what's the difference between CO2 and the other greenhouse gases? Basically, CO2 stays in the atmosphere pretty much permanently once it's up there. This is a cumulative problem, and the longer we delay tackling climate change, the more CO2 will go into the atmosphere and stay there, and the higher temperatures will be as a result. That's why it's such an urgent problem. That's not true of all greenhouse gases. So you'll see methane is a very potent greenhouse gas, but it also dies away relatively quickly. I think that typically for about, it's in the atmosphere for typically around 12 years before it oxidizes to CO2 actually. So it still has some warming effect, as you see along the bottom. That blue line continues to have an effect because it's become CO2 at that point. And nitrous oxide is another long-lived greenhouse gas, but it is at least decaying in the atmosphere on very long time scales. So there's different dynamics going on with different greenhouse gases, and that's important to recognize. Our net zero target in the UK is for a basket of greenhouse gases, and so it's weighting these gases differently. And the way it does that is on the warming effect over 100 years, what's called the 100-year global warming potential. Now there are different metrics and so on, but that's the one that's used as standard internationally. So that's what we've got. So sorry about the quality of this picture. I had to copy it in from a PDF, and it hasn't survived the transition very well. But hopefully it's fairly clear. What we've got on the y-axis is the date of peak warming. This is, sorry, each of these dots is from a simulation, a climate model of what might happen to emissions in the future globally, and what will happen to warming as a result. So the y-axis is the date of peak warming as we reduce emissions through net zero, and look at the temperature change globally. On the x-axis, we've got the date of net zero emissions, and we've got the blue ones as all greenhouse gases, and we've got the red ones as CO2 only. And you can see a much stronger correlation here. The green line would be if we get to net zero emissions in that year, does warming also peak in that year? And you can see that the red dots are largely clustered around that green line, whereas the blue dots are kind of scattered around below. So it really is CO2 that we're mainly concerned with, but we also have to bear down on the other gases, and that's why we have a net zero target that includes those, because although net zero CO2 is in a sense scientifically something that we might want to target, we don't want to let the other gases out of our attention. Okay, so what does that mean in terms of what everyone has to do globally? This is a picture that shows emissions per capita for the world. So this is very much sort of, you know, not saying that everyone should do exactly the same, but just trying to compare. And you can see historically that the world has had emissions roughly flat over the last 30 years on a per capita basis, but emissions have grown on an absolute basis because, of course, global population has been rising. But during that period, the UK has actually reduced its emissions by 40-something%, depends which year you calculate it, and 2020 maybe isn't the most representative year, but it's 40-something% down in the UK over that period, and we've now reached something close to the global average in terms of per capita emissions, which for a rich industrialized country is a significant achievement. If we then look at what might be required to meet either 1.5 degrees, or we also have well below 2 degrees, or you know, good chance of staying below 2 degrees on here. You'll see, and then the purple line is the UK path that we've now placed in legislation. You'll see that actually the UK path starts to overtake some of these other paths and gets to net zero earlier than them. So, you know, we're talking about, but actually if you look at the slope of what's happened over the last 30 years in the UK and the slope of what needs to happen over the next 20 or 30 years is pretty similar. So we've already achieved a fair amount. But what's happened in the UK now needs to be replicated globally in terms of that rate of emissions reduction on a per capita basis. I won't go through this very busy slide much other than to say, of course, everyone needs to reduce emissions, and that's how you get to global net zero. The UK, the strong purple line there, has to be one of the earlier countries to get to net zero, but everyone needs to get there in the end. Okay, so how do we think about what the UK share of that is? That's one of the challenges that we always have in terms of setting targets is, well, we can work out roughly what we need to do at the international level to limit warming to below a certain level. But then how do you share out the responsibility that there's a certain amount of emissions allowed to stay within that carbon budget, as it's called, at a global level, but how do you decide who gets what share? And so there are different ways of doing that, and you can see in the chart on the left hand side, depending on well, both the temperature target, but then also the methodology for how one apportions out those that carbon budget, you can end up with very different targets essentially at UK level. But the thing that's guided us the most is the principle in the Paris Agreement of highest possible ambition, that every country should take its highest possible ambition, and that should be what it pursues. And so we very much focused, we've used the left-hand side, the top-down and the science-based calculations as a sense check, but we've very much focused more on the bottom-up pathways on the right hand side here about what's actually achievable in the UK if we take an interpretation of highest possible ambition. And of course it is possible to argue about what's possible and what's not, and we can maybe pick up some of those in Q&A. I'm now going to talk through the UK path in a bit more detail so that you understand actually what do those pathways entail. And you'll see that we've got 5 pathways that get to net zero in or before 2050. I will focus mostly on what we call our balanced net zero pathway, which is what has underpinned the UK's 6th carbon budget that's now placed in legislation. Okay, so a couple of slides just saying what's happened to date in the UK. You'll see the line at the top there is UK GDP, which has been largely growing over the last 30 years, though with honourable exceptions, obviously, last year and you know, the financial crisis as well. Generally speaking, the UK's territorial emissions, which is what the carbon budgets, what the legal framework in the UK targets, which is the yellow line, has been gradually going down, maybe not as quickly as one would like, but it has been going down even as the UK grows. And the other measure that we're interested in is the UK's consumption emissions. So that's not only what emissions occur in the UK, but actually what consumption occurs in the UK, and what emissions result from that, regardless of whether the emissions happen in the UK or in China or in the rest of Europe or wherever. And you can see that that's also been falling, but slightly less quickly than the territorial emissions, but particularly since the global financial crisis, actually it's been falling at about the same rate as territorial emissions. Before that, we were really struggling to bring that down as consumption continued to increase. And in terms of sectoral emissions in the UK, so this shows emissions on a sector by sector basis. You can see a lot of fairly horizontal lines here over time. This shows the last 20 years or so of data on a sector by sector basis. The one that really stands out here is electricity supply. So in 2000 and even back in 2010 or 2012, it was by far the biggest emitting sector of the UK economy. But since 2012, we've reduced emissions from electricity generation in the UK by over 70% in less than a decade. And that's happened through a number of routes. We've priced coal off the electricity system by introducing carbon pricing. We've borne down on electricity demand, largely through regulation, things like more energy efficient light bulbs, more efficient fridges, more efficient washing machines, etc. That regulation, you can't even buy what the best washing machine might have been 10 or 15 years ago, would simply not be on sale now, because the regulation and the labelling has made that so much better. And then the third element is the contracts for low carbon and specifically for renewable generation over that time. And we've seen spectacular cost reductions in, of course, solar, but also wind generation and particularly offshore wind generation in the UK, such that now those renewable energy sources are cost competitive with fossil fuel generation, even before the price spike that we've seen over the last few months. Those things were just as cost effective, even ignoring the carbon and even ignoring the recent price spike. And clearly the carbon and the price spike give us every reason to invest as quickly as we can in expanding renewable generation in the UK. And we've got further auctions coming over the next few months to procure what I hope will be huge amounts of offshore wind, plus onshore wind, plus solar, and so on, to help accelerate that bit of the transition. And I'll come on to the importance of the electricity sector. It's not just about getting rid of that last 40-something megatons of emissions. It's also its central role in getting rid of emissions in the other sectors. Okay, so how do we do our assessment of what the carbon budget should be, the sixth carbon budget in particular, which is what we recommended last year? We take a bottom-up approach. We look at all the sectors, look at the costs of actions to reduce emissions in every sector, and joining those up as well. So what's happening in the electricity sector is really important for what might happen in the building sector or the industry sector, because ultimately electrification of processes, adoption of heat pumps for buildings, electrification of processes in industry is one of the key ways of reducing emissions in those sectors. So there's an interaction there between those sectors as well. But we also are required to and do take account of a range of considerations at the bottom here: fiscal impacts on the economy, and particularly on fuel poverty, security of supply, competitiveness, and wider social things, including health. So it's a whole economy assessment of where are the opportunities to reduce emissions and what makes sense. And there's a huge amount of both modelling but also consideration of some of the softer things around public acceptance and how quickly can you build up supply chains, and how quickly will people get used to the idea of, your next car being an electric car, or your next boiler replacement being a heat pump. So this is the set of targets that we have in legislation. You can see again the historical path for emissions broadly at the rate that we need to continue over the next 20 to 30 years. There's a number of things on here, and I won't go hugely into the aviation and shipping stuff, but for the first time we now have emissions from the UK share of international aviation and international shipping in the carbon budget. It was always kind of outside but taken account of before, but we've managed to get the government to agree to include it now. And the reduction by 2035 is a 78% reduction on 1990 emissions. That's a 63% reduction on 2019. So essentially from the point where we recommended it, there was 30 years left to get to net zero, but we had over 60% of the emissions reduction happening in the first half of that period. So we front loaded that, and we've done that because, as I set out earlier, climate change is a cumulative problem, and the earlier you can get to low level of emissions, the lower the overall impact is on the climate. If we could have gone faster and set out a pathway for how we think that is feasible and plausible, then we would have done that. But ultimately, there are a number of constraints and reasons why it's more difficult to go quickly than this. Good. All right. So why is the path front loaded? So the UK's global contribution, highest possible ambition. I talked about that earlier. Investing for the recovery, so that's really important. That the green recovery, as it's often called, from COVID. There are a number of ways of both tackling climate change and adapting to climate change that are actually quite investment heavy. And if you want the economy to recover economically, investment is a good thing, and a number of those measures are really quite job intensive as well. So who knows where we'll be in a few months in job terms, but that was particularly important consideration over the last couple of years or so. There's momentum for net zero, and it absolutely makes sense to build on that and to try and reduce emissions as quickly as we can during the 2020s and prepare for the even more rapid reduction in emissions required in the 2030s to meet those targets. And actually, it also, working back from the 2050 target, you do need to make progress in every sector if you're going to get to net zero, and that means starting now. And particularly, some of the difficult sectors like decarbonising buildings, if we don't start now, we're just not going to get to where we need to get to by 2050. And there are, of course, a range of benefits and opportunities as well in sectors, which means that it's desirable from a societal perspective to take many of these actions, even ignoring the climate change aspect. Okay, so this is our path. This is our balanced pathway. And this wedge chart, as we call it, is helps to explain what are the things that contribute to emissions reduction over the path to net zero by 2050. And broadly speaking, we can divide them into 4 categories. One is demand side, both reduced demand for emitting activities, so that might be flying less, it might be eating less red meat, and so on, but also efficiency improvement, both energy efficiency but also resource efficiency, making products last longer, etc. We've got then expansion of low carbon energy, so that's decarbonising the electricity in particular that we already supply, and pushing as much of the fossil fuel out of that as we can. And the Prime Minister's announcement this week of the 2035 date for all electricity generation to be decarbonised is great, and that was based on our recommendation. I'll come on to talk about that in a minute. Then the third wedge is huge, and this is basically pushing out fossil fuels used across the economy, so in transport, in industry, in buildings, and replacing those with zero carbon energy at the point of use. So whether that's electricity, which is the huge wedge there, the orange, whether it's hydrogen, which we have in our scenarios, essentially only where electrification is not feasible. So it's additional to that electrification. We think electrify where you can, and where you can't, yes, use hydrogen. And then there's important roles for carbon capture, both from industry and then also greenhouse gas removal. So the final wedge is offsetting emissions, sometimes called greenhouse gas removals, and that's both the natural carbon storage. So growing trees is the obvious example, but it's also restoring peatland and soil carbon and a range of things there. And then engineered greenhouse gas removals, which is essentially using carbon capture and storage to take carbon out of the atmosphere, whether that's direct air capture plants, which are starting to become available and estimates suggest might be cost competitive over the next few decades, or whether it's burning biomass in a power plant. And of course, the carbon came from the atmosphere in the first place, but if you burn it in a power plant and capture the CO2 emissions and bury them, then that's a net negative process, assuming your bioenergy came from a sensible place in the first place. Okay, so the path to net zero is not all about technology. So you saw on the chart that showed sectoral emissions over time, a lot of the reduction that we've seen has been in the power sector, for example, and much of progress elsewhere is things like stopping biodegradable waste going to landfill. A lot of these things so far have not actually required that much engagement from the public. Most people, stop a random person in the street, they probably won't know that our electricity supplies massively decarbonised over the last decade. It's just not well known because it hasn't required any engagement. We can't get to net zero by trying to repeat that. Over 60% of the emissions reductions that we have to 2035 entail some kind of engagement from the public, whether that's the 16% that's direct kind of behaviour change, such as walking and cycling more instead of using cars, eating less red meat, etc., or whether it's the 40-something% where it's a combination of a behaviour change and a technology. For example, making your next car an electric car is both a behaviour change because you're shifting to a different kind of car, and you also need different behaviours once you've got that car in terms of plugging it in every night and so on. Though actually, that's probably a pretty attractive prospect at the moment, given the difficulty of getting petrol. And yeah, it's only around 40% of the emissions reductions that will be technology only in the way that has been dominant over the last 20 years or so. Okay, so I said I'd talk about the electricity decarbonisation target for 2035. Really pleased about that. That was one of the key pieces of advice beyond the legislated target for emissions in terms of our recommendation of how to achieve it. 100% clean electricity from 2035. That's a mixture of technologies. In our scenarios, we have a dominant role for variable renewables, largely wind, but also solar, reaching around 80% by 2050 and around 70% by 2035, by the date where everything needs to be decarbonised. That's basically because it's very close to zero carbon generation from those sources, and B, the costs are very attractive. We also have roles for nuclear in there, but it's smaller. It would be bigger if the costs were lower, essentially. We've looked at that and we've concluded that based on the information that we have now, we think renewables is a more cost-effective way to go. But the thing about renewables are that the wind doesn't always blow and the sun doesn't always shine, especially at night. So you need other forms of electricity generation to complement those. But even when you have those other forms of electricity generation, that's still a cost-effective mix, and more cost-effective, for example, than we think the nuclear, even though it generates kind of in a constant way. The other thing you need to take into account is actually we don't need the same amount of electricity in every hour of the year, and sometimes there will just be peaks in demand, and particularly as we electrify heating in the UK, then there'll be peaks in demand in the winter. Actually, offshore wind, for example, generates significantly more in the winter than it does in the summer. So you've got to take into account those profiles, but also you've just got to have enough capacity on the system that can generate on demand, so that when there is a wind lull, you still are able to meet demand. So we've thought about all of that, and we've thought about actually what are the other things that need to be on the system. And the forms of electricity generation that can be low carbon but very responsive essentially are fossil gas used but with CCS, with carbon capture and storage, to take the carbon out of it, and be largely decarbonised. We think up to an 85% reduction in emissions compared to just burning gas without CCS as we do today. And hydrogen is the other one, which gives a similar emissions reduction. And the hydrogen plants might be those that are only running 10 or 20% of the hours of the year, whereas the gas CCS plants might be running 50% of the hours of the year, that sort of thing. But that's how we balance the system in our assessment. And we need to scale up those solutions. We don't have any of those solutions running in the UK at the moment. So the key thing in meeting the 2035 date for us is scaling up the gas CCS and the hydrogen solutions, as well as having a plan for how we're going to achieve that 2035 target overall. Okay, a little bit of other stuff about what needs to happen over time. We find phase out dates are a really helpful way of communicating what's going on in our society, but in a way that people can actually engage with and so on. So you may be aware of the government having announced a 2030 phase out date for sales of petrol and diesel cars and vans. In our scenario, actually, it was 2032. Government's gone for 2030, but with a weird kind of, some petrol vehicles will be allowed if they've got zero emission capability thing, which hasn't yet been defined. So it's kind of a bit vague at the moment, but that's the sort of thing, early 2030s phase out there. And we'll need similar in terms of fossil fuel heating in our homes. I've talked about the electricity generation thing. Heavy goods vehicles, a bit more difficult, but we still think you can phase out new diesel trucks by 2040. And the solution there is actually it could be electricity, it could be hydrogen, but we're going to need a common solution with other neighbouring countries so that these vehicles can cross borders. And there's some waste things there, and particularly energy from waste. That's been a growing source of emissions over time, and that's something that we really need to tackle urgently. We'll if we're going to get to net zero, we need to crack it in the next 10 years. It's not only the emissions reductions that we get in that period, it's also putting together the policy frameworks that enable us to get to every new car being electric by 2030 or very soon after, similar on heating. That once we've got those in place and once we're achieving those levels of sales, actually then a lot of the emissions reductions that we're going to get are going to be after 2030, but because of the policy framework that we've got in place, just as we turn over the vehicle stock, as we turn over the stock of heating appliances, as those existing high carbon assets come to the end of their life and get replaced by low carbon assets. So that's the crucial thing there. So we're cracking the problem over the next 10 years in terms of the policy challenge, but it still takes a while to feed through into the full set of emissions reductions. A little bit on the economics, just to say there's a huge investment required here, about an extra £50 billion a year of investment compared to what we do at the moment, compared to business as usual. But that comes with a big return as well economically. So by 2050, we think the fuel savings, the operational savings from the transition actually start to outweigh the investment costs. So above the axis we've got the investment costs, and below the axis we've got the savings. So this is a kind of a 20 or 30 year kind of one-off investment push to get us on track to net zero, and actually by 2050 it starts to save us money over time. And of course the transition comes with a range of benefits that are not financial, such as to health and so on, as well as obviously having a livable climate, which is the whole point of the exercise. So a final slide on pathways, just to say, net zero is net because we don't think we can get all sources of emissions to zero. This chart shows above the x-axis, it's got the remaining sources of emissions, and we've kind of grouped that into aviation, agriculture and everything else, because the everything else is broadly, as you see in the top right there, across surface transport, power generation, buildings, shipping, and lots of manufacturing. We think we can get pretty close to zero emissions in those things. But aviation, agriculture, and a few assorted other bits can't get to zero. And of course, to get to net zero, you need to have things balancing that out. We do have significant land use changes in our scenarios to absorb the carbon from the atmosphere in natural ways, growing trees, restoring peatland, and so on. But you can't do that to a sufficient level to get to net zero overall without the engineered greenhouse gas removals in black there to get you all the way to net zero in our assessment. And even those land use changes that do absorb the carbon in natural ways are hugely reliant on behavioural changes. I talked earlier about red meat. It's not just the agricultural emissions that we save from consuming less red meat. We also free up land that the animals graze on to then be able to plant the trees in afforest areas and so on as well. So that's a crucially important dimension of it. But in our assessment, we can't get to net zero without a significant role for engineered greenhouse gas removals. Okay, a little bit here on air quality. I won't go into detail here, but we can pick it up in the questions maybe. We've assessed our pathways largely on the basis of climate, but we've also taken into account wider things, and one of the wider things is health, and we want to ensure that, you know, in pursuing net zero for climate, it has positive impacts on air quality rather than the reverse. And so this is an assessment that was done by DEFRA's air quality expert group on the things that are in our scenarios and which ones are positive for air quality, which ones are neutral, and which ones are negative. And largely speaking, it's a positive story, but with a few honourable exceptions. And I think I've talked enough about the co-benefits, so I will stop there. Thank you very much.
Thank you, David. That was a fantastic overview. And I can see we've got lots of questions coming in. So I'd encourage everyone else in the audience to take this opportunity to ask David while we have him available to us. But if I may, I'd like to kind of start off with one myself, David. It almost seems too simple to be true, the relationship that you highlighted at the start between cumulative emissions and peak warming. But yet we also hear about campaigners talking about we only have so many years to fix the problem. Is there a cliff edge, or is that kind of straight line relationship the main conclusion we should draw?
So it's a really good question, John. I mean, there's no real cliff edge. It is just, it's a cumulative problem. The earlier we act and the more strongly we act, the better the impact will be in terms of the climate we end up with. But those cliff edge messages happen for a reason, and the reason they happen is because that's how you get people to act. You can't say, well, it'd be better if you do it this year, but it's fine if you do it next year. It'll only be a tiny bit worse. That's not how you get people to act. The way you get people to act is to say, you have to do it this year.
Yeah.
And you don't give them the option. And that is, I mean, part of the benefit of the Climate Change Act and the target framework. I mean, targets are not valuable in themselves, but they hold you to account, and they actually say, these are the things you need to do. This is when you need to do them by. And we've got a monitoring process and so on that says, if the targets are being missed, then, you know, we're holding government to account. Otherwise, it's just, you know, as a kind of slow moving thing. I mean, we've got to 2021. We've known about the greenhouse effect for over a century in terms of the basic scientific mechanism of CO2 trapping heat in the atmosphere, and we've known climate change has been a problem, you know, at a global level for over 30 years, and yet, you know, emissions have carried on rising over that time. So it's the challenge is very much getting people to act, and you can understand why people talk about cliff edges, but the physical reality is no, not really. That, you know, people talk about as well tipping points, and if we don't act, you know, in the next X number of years, the permafrost's going to melt and release all the methane, which is going to make climate change worse and whatever. I mean, the scientific literature does take those things into account, and actually those things, I mean, if they're going to get triggered in the next 10 years, if we don't act, frankly, they're going to get triggered in 20 or 30 years time, because the lags in the system means that the temperature of the Earth is going to carry on increasing until we get to net zero, which is going to be mid-century at least. So yeah, it's difficult. One of the biggest challenges about climate change is that it doesn't really conform to the way humans behave. and that's socially that's one of the biggest challenges. We have the solutions to reduce emissions, and it's just about deploying them. But actually, that's more difficult than it sounds.
And so in terms of kind of interpreting that physical science into policy frameworks, we've got both a net zero target and carbon budget. Which of those do you think is kind of most useful in organising society's response to climate change?
Lots of good questions this morning. The net zero target, I think, is particularly valuable because it's got a simplicity that people broadly understand. I think, I mean, we've had a long-term target in the Climate Change Act for nearly 13 years now, which used to be the 80% reduction target that was enacted in 2008 that we also recommended at that point. But the problem with the 80% target was, well, there's 20% of emissions you're allowed to leave. And the problem with that is more than 20% of emitters think they're in the 20%. So that actually wasn't that helpful in terms of ensuring that the action was taken, particularly in difficult sectors such as home heating, anything that needs hydrogen, anything that needs carbon capture and storage. And so the net zero target is hugely valuable in terms of the simplicity of the messaging, even with that net bit in there, which is kind of still a little bit of, well, we could just not do anything and then we'll just pay for some greenhouse gas removals. But it's a stronger message there. Everyone has to do everything they can, and then yes, we're going to have a little bit left at the end that we'll have to balance with removals. But broadly speaking, it's a message that gains traction. So I think that the 2050 target, in a sense, is stronger now than it was when it changed a couple of years ago. The carbon budgets, I mean, I think both the target for 2030, which isn't actually the carbon budget target, it's the UK's international commitment under the UN process, and the sixth carbon budget, which is for the mid 2030s. I think are more important in the sense that they drive near-term action and really concentrate the government's mind. So in that sense, I'd say they're really important. But actually, historically, the first three carbon budgets that we set, so we set them in 2008, and those ran from 2008 to 2022, the first 15-year period. So we're still in the third carbon budget period now. Those were actually too loose. We didn't know, for example, the full impacts of the financial crisis and what that was going to do to the economy and so on. So we actually set them too loose in 2008. And so those haven't been very helpful so far. So I guess I'm taking a slightly rose-tinted view of things. That on the one hand, the 80% target wasn't that helpful, and the carbon budgets so far haven't been that helpful. But the future carbon budgets and the net zero target, they're amazing, and they're going to drive all the action. I don't know which is more important, but they serve different purposes. I think the net zero gives you a clarity of what you're trying to achieve long term, the kinds of solutions that you need to take into account. Hybrid vehicles, the Toyota Prius, are not going to help you reach net zero because they still burn petrol. If you want net zero, you need to switch to electric vehicles. And I think that clarity is really important. But on the other hand, it's the near-term carbon budgets that, a politician who's in power now might actually worry that they might be breaking the law by, not for the third carbon budget, but the fourth carbon budget period, and that might be missed, and that starts in 2023. So that's much more worrying if you're a politician.
That was a question that someone asked in one of our previous webinars in this series, was, does somebody go to jail if the Climate Change Act is broken? So
I used to jokingly respond that the then Chancellor would go to jail, but as I've become more senior in the CCC, I've given up identifying who that person would be. No one goes to jail, and the Climate Change Act is essentially, it is a legal mechanism, but ultimately it's a reputational mechanism. It's basically putting in place something that makes it really inconvenient for the government if they just don't do enough on climate. They then they'll be embarrassed by missing the targets. Well, some governments have less shame than others, but hopefully that's effective. But it's also then a legal thing in terms of judicial review and getting dragged through the courts because the targets have been missed, and being directed by judges to sort out their strategy and so on. So no one goes to jail, but there's still a legal process there that can be enacted, and it's also just embarrassing if the UK starts missing its targets. But even though climate action has not been strong enough over the last decade in the UK, we still haven't started missing the targets yet, because unfortunately the targets were a bit too loose. So we haven't got to that dynamic yet, but I think we will start to. I mean, the fourth carbon budget, we set it in 2010, and it still happens to be roughly in the right place. So we did better with that one than we did with the first 3 carbon budgets. So that still looks very stretching now, even on the path to net zero. So fingers crossed that will be met, and that will indicate that we're doing all the things that we need to be doing, both in that period, but also for the longer term in terms of 5th and 6th carbon budgets and net zero.
And final question I'd put to you, David, is kind of related to that. We always know that there's uncertainty in physical systems and our representations of them. Do the uncertainties in carbon budgets and our understanding make any qualitative difference to the conclusions that you would draw here? Absolutely not. No, I mean, I think it is clear that there are still uncertainties. Those are gradually narrowing, and I think we've had a pretty good understanding, over certainly the last decade and longer, really, about what's going on. Fundamentally, we understand the physical mechanisms of what's going on in terms of the greenhouse gases trapping heat. And of course, it may be that because the climate is a complex system, there are little bits at the margins that we get wrong, but fundamentally, we understand what those physical processes are. We understand that it's a cumulative problem, and we understand what it is that we need to do to stop the warming effect, which is to get to net zero emissions. So all of that is true. And the biggest uncertainties, to be honest, are social things rather than physical science things. It's not should we reduce emissions, but how can we reduce emissions? What is the public going to accept? Are politicians going to push for climate action in the way that they should? Is the political will there? It's the social uncertainties, I think, that dominate over the physical science uncertainty. Super, thanks, David. So turning to the questions we've had come in while you've been talking, we've had a few about electric vehicles, and so the first is to ask what the impact and the increase of EVs will have on the emissions from electricity. Yeah, so that's really important, and I note that there's been something in the FT, I think it was yesterday, looking at kind of life cycle emissions, and actually are EVs as clean as they claim to be, and all of those things. And actually the answer is they're really clean, and they're only going to get cleaner. Even if you go out tomorrow and buy an electric car to replace your petrol car, it will already be probably at least 50% cleaner than your petrol car. I haven't done the latest calculations based on the latest electricity supply, but more than 50% cleaner. But in 5 years' time, it's going to be much cleaner than a petrol car, and in 10 years' time, it's going to be even cleaner. So, over the lifetime of a car you buy tomorrow, it's probably going to be 80% plus cleaner than a petrol car that you might buy. But we do have to take those things into account. So one of the things that I should have said and didn't in terms of the pathway, that huge wedge of orange on the wedge chart in terms of the electrification means a huge scaling up of electricity generation that we need over the period to 2050. Our estimate is at least a doubling, and it's a doubling if you do everything you should do in terms of energy efficiency and you use relatively high efficiency electrification solutions. So electric vehicles are really efficient, and that's one of their advantages over petrol cars, and actually means that they're going to be much cheaper to run than petrol cars, regardless of what you think about climate change. But also heat pumps, which are roughly 3 times as efficient as a gas boiler. But of course we can run our home heating on electricity in other ways that generate more instant heat but are much less efficient. And if we do that, we might be talking about a tripling of electricity demand or even more by 2050. So the really important thing is, decarbonize the electricity generation that we already have, but expand then the low carbon generation for at least a doubling by 2050. So we tend to think of that in 2 phases. One is the decarbonisation phase, and the other one is the kind of expansion phase of applying low carbon electricity to the other sectors. In reality, there's some overlap between them as we're now 15% of new car sales in September were electric. So we're not at Norway levels where I think it's over 90% now. Yeah. But we're heading in that direction. So we will have increased electricity demand this decade, but we're also building out
renewables at a rapid rate, going from around 10 gigawatts of offshore wind at the moment to 40 by 2030. And so that if renewable generation increases can keep pace with the increases in demand, then it doesn't necessarily mean extra emissions from the demand from electric vehicles. So that's a good news story. And even if you don't increase the low carbon generation, running an electric car on electricity from a gas-fired power plant is still better for the climate than running a petrol car. So overall, it's very clear. If we had a lot of coal in the electricity system, it starts to look more balanced, but of course coal is down to less than 2% of UK electricity generation now, and will be off the system in about 3 years. So that's just in the UK context, that's completely a non-starter. But it varies in different places around the world.
Super, thanks, David. And so leading on from that, there comes this question about energy storage in the grid, managing the peaks. Could you say a little bit about how peak loads are managed in your assessments?
Sure. So I mean that's really important, and particularly as I said earlier, as we go to electric heating, I mean two things that happen there. One is a big seasonal swing in electricity demand. Obviously the most seasonal aspect of our energy demands are for heating, for obvious reasons. That when it's cold, we need more warmth to be generated from the energy system, and if that's from the electricity system, then that makes demand for electricity much more seasonal. But the other thing is there are particularly cold days, and what happens on a cold day is A, you need more heat coming out of your radiator, but B, your heat pump becomes less efficient at turning electricity into heat. So that can lead to big spikes. Now that's still potentially manageable, but it's pretty challenging, both from then the physical grid that we've got, the wires that carry the electricity to your home, but also then how do you generate that electricity, and how do you generate in a low carbon way. So we've thought about, I mean, one of the really important things, I talked about hydrogen, but I didn't talk in detail. Hydrogen can be really valuable to the energy system in terms of meeting those spikes in energy demand. And you can do that in two ways, actually. One is you can pipe hydrogen to homes and have something called a hybrid heating system, where you have a heat pump doing most of your heating across the winter, but on the coldest days, the heat pump gets supplemented by a hydrogen boiler that just kicks in to give you that extra heat that you need. And that avoids the big spikes then that you get in terms of electricity demand. I've actually got a hybrid heating system in my home. I've got a heat pump out the back. At the moment, all of my heating, and yes, I did turn it on last week, all of my heating is from the heat pump. But if it gets to -7 in January, it's going to be a combination of my fossil gas boiler at the moment and the heat pump. In future, that fossil gas boiler might be replaced by a hydrogen boiler, and it might still only be doing 10% of my heating. But on the coldest days, that's still really important. But the other role for hydrogen could be, actually, we could completely electrify home heating and have all of those spikes. And then the question is, well, how do you meet those spikes? And one of the roles of hydrogen can be hydrogen powered electricity generation. So you store the hydrogen, and then on those really cold days where the demand is spiking, you put that hydrogen through a turbine and generate electricity, and that's how you help to meet the spike. So whether you're using hydrogen at the kind of electricity system level or the more distributed home level, it seems to have a really important role in terms of meeting heating demands on those coldest days, as well as kind of managing the system more generally and so on.
We've got two related questions about the Earth and heat from the Earth. So one is asking, is there a role for geothermal power generation, I'm presuming in the UK? And another talking about heat pumps being less efficient when it's cold. Does that only apply to air source systems or ground source systems as well?
Great. So I'll take the second one first, because I've just been talking about heat pumps. So it applies to both, but it applies much more to air source heat pumps, because fundamentally on a cold day, obviously the air is cold, and so that makes a difference. Whereas the temperature of the ground varies a lot less from day to day, and certainly It does vary, of course, across the seasons, but the temperature is much more stable in the ground, and therefore you have much less of that effect. But ground source heat pumps have their own challenges in terms of installation, and they are not going to be, we are not going to be able to install 22 million ground source heat pumps across the UK. So yeah, they definitely have an important role, and they have some better characteristics, but we're going to need mass rollout of air source heat pumps if we're going to electrify fully. On geothermal, there's a lot of people talk very positively about geothermal. I'm not up completely on the latest developments, but that could be really positive. I've worked a fair amount on the fracking side, and some of the techniques that have been used to develop fracking, which is obviously bad for the climate, can help in terms of geothermal and developing new sources of heating. That's particularly valuable because it's a different kind of renewable energy to what you get from a solar panel or a wind turbine, because in the form of heat, I mean, one of the most difficult things to crack is home heating decarbonisation. And if we've got renewable heat coming out of the ground, and we can put that, for example, into heat networks and pipe the heat around to homes, that can be a really good solution. So actually, geothermal traditionally has been thought of as a means of generating electricity, and of course it can do, but actually in some ways the most valuable thing is to go directly to heating homes with it. So yeah, that's promising. It obviously varies different parts of the world and different parts of the UK, the potential for that, but yeah, it's absolutely part of the mix there.
So again, thinking about the kind of the geosciences, we've got a question that posits that CCS has been talked about for decades, but never seems to have been used at scale. Is that the case? What's the situation with CCS in comparison to the other ways of meeting peak demands?
Yeah, so I meat that's an important question. There is CCS globally. There are several dozen projects at different stages, but many operational. The problem with CCS is it's always going to add cost to what you're doing if you don't care about climate change and you're just burning fossil fuels. Actually, some of the projects that are happening globally on CCS take the CO2 and push it into oil fields to produce more oil. So, is that good for the climate? Is it not good for the climate? It depends on your view of what would, where would the oil have come from otherwise. But that's something that places a value on the CO2, and that's not something we've done enough globally as a society, is putting a value on that CO2 saving. And if you don't put a value on that CO2 saving, adding extra cost in order to capture the CO2 and bury it is just not going to be, no one's going to want to do that. So we've really struggled with that. And I've always said, if you're not serious about CCS, you're not serious about keeping climate change under 2 degrees, because fundamentally, there's a lot that we can do with renewables and electric cars and whatever. They're going to save us money, but you're not going to do enough to get to net zero emissions and without the CCS stuff. So we're going to have to pay for that. It's only a minority bit of the solution. It is affordable within the aggregate picture, but we just haven't been willing to sign the check so far, and that needs to change. And that's one of the litmus tests of the UK's net zero strategy, is actually, are we actually finally going to spend this legendary £1 billion that we've had allocated for essentially a decade for carbon capture and storage?
And we're coming to the end of our time now, David. Just the final question that I would ask is, we focused here on CO2, but methane is obviously a potent greenhouse gas that gets a lot of attention. Could you say a little bit about methane in agriculture? So we've had a question about the cultivation of rice, but many people are also interested in their diet, and you mentioned avoiding red meat. How much of a difference does that make to the UK scenarios?
Yeah, so I mean, it's people often talk about different climate metrics and how important is methane compared to CO2 and so on, which there are scientific debates and so on you can have, but fundamentally what we need to do is reduce methane as rapidly as we can and reduce CO2 as rapidly as we can. So in a sense, how you trade off between those is kind of less important. So yeah, it's really important. The UK is one of the countries that signed up to rapid methane reductions as part of a global initiative over the next 10 years, and that's really important. Rice is an interesting example, because yes, methane does come from rice production, but on a like-for-like basis, actually, a lot more comes from red meat in particular, and dairy food production. So those are the real the ones we need to target in terms of agricultural emissions, and they also take up a lot of land, which then has the opportunity to be used in other ways. So if we're interested in methane, it is largely the agricultural sector, to some extent the waste sector, and to some extent the fossil fuel sector. We need to bear down on all of those, but in particular, what you can do is eat less red meat, eat less dairy. I really struggle to cut down on my cheese, but I am veggie, so I'm doing all right on that, but not. I can still do better, as long as no one offers me halloumi. Right, I think we're done.
We've come to time, David. Thanks ever so much for your input there, and thanks to the audience as well for all their questions. I'm very sorry we didn't manage to get through all of them, but some of these issues will be touched upon in the rest of our programme. We've got multiple panels about batteries, energy storage, electric vehicles, hydrogen. Please go to our website to rsc.li/COP26 to find out where you can join those panels live or watch back on the recordings. Yes, so just once again, thank you, David. Thank you, everyone, for joining us. This has been the Royal Society of Chemistry. Looking forward to COP26. Bye now.